Next thing is structure of NaCl. So structure of sodium chloride. Structure of sodium chloride. So Na plus and Cl minus. So if you see, the size of the cation and anions are almost equal in this case. So if you draw the cubic FCC, this sodium chloride is a FCC crystalline structures. So FCC structure, total number of sodium plus and Cl minus present are total number of sodium plus, total number of Na plus and Cl minus ions are 27. So if you draw the structure of this FCC structure, you can find out that total number of atoms present are the 27. So next thing is, in that 14 are sodium plus 13 are Cl minus ions. Cl minus, or it may be 13 sodium plus or 14 Na plus ions. So number of sodium plus ion per unit cell. So number of sodium plus ions per unit cell is equals to, if you see FCC 8 into 1 by 8 plus 6 into 1 by 2, that will give you the 8 will get cancelled, 3, so 1 plus 3, that is equals to 4 atoms. So number of chloride ions per unit cell. So number of Cl minus ions per unit cell is equals to, if you see how many edges are there, 12 edges into 1 by 4 plus 1, that is also 12, 4 3s are 12 plus 1, that will give you the 4. So this is 3 plus 1 is equals to 4. So next thing is number of NaCl formula unit cell or structural unit cell will be 4. The important thing is coordination number per sodium plus is 6, and coordination number for Cl minus also 6. So next thing is relationship between the edge length and radius of the sphere is equals to, see, if you take this is the sodium plus and Cl minus ion, then this will give you here. So here R plus R and R plus R, so 2 R, so R Na plus 2 R Cl minus plus 2 R Cl minus plus R Na plus, that will give you the A. So total it will be 2 into R of Na plus R into Cl minus is equals to A. So R of Na plus R of Cl minus is equals to A by 2. This is the relationship between the here, if you take this is the Na plus, this is Cl minus, and this is Na plus. So distance between here is R and here R, this is the circle, so it has radius from center to the outer shell, and here is R plus R, this is the diameter of the chlorine, and this is also radius of the sodium plus. So first if you draw the structure of this sodium chloride, this will give you clear idea how many atoms are there and how many molecules are there. So first you take the corners, draw the cube. So here, if this is the cubical structure means how many atoms are present here. So 1 2 3 4 5 6, 7, 8 atoms are there, and it is a face centered. So at the face centered it has atoms. So on the faces it has atoms. So this is the one atom here, this is atom, and in center there is a void is present. Void is present here, so void is present, and here you can draw another face and void. So here I can draw another face, and this you can join this one and this one you can join. Next thing is, if you see here also one void will be there, void space will be there. So another thing is, here is the one atom at the face, and if you see this is the another atom. If you take this one, so here you have this one, this is the face thing, and at the center also we have octahedral voids. Octahedral voids are present here. So here octahedral voids, and this is the face, and here on adjacent so some octahedral voids are present. So how many octahedral voids? 3 octahedral voids are present. So if you draw like this structure, so here if you take, this is the, let's assume this is Cl minus, then it is also Cl minus, and Cl minus and sodium pluses are present. Cl minus, how many Cl minus are present? So firstly you see this one here, how many Cl minus? Let us assume 13 Cl minus. So Cl minus, and here is a Cl minus, and Cl minus, Cl minus. Next thing is sodium plus. So this is the sodium chloride structure. If you see chloride ions 1, so 8 corners, 8 chloride ions. So 8 corners, 8 chloride ions at corners, and on faces 6 chloride ions. So faces total 14 Cl minus ions, and if you see the edges, if you take edges, 12 edges, sodium plus ions are 12 sodium plus ions, and at the center 1 sodium plus ion. So this total will give you the 13 Na plus ions. So total atoms are, total is equals to 14 Cl minus ions plus 13 sodium plus ions is equals to 27 atoms total is present in the sodium chloride structure. So this is about the sodium chloride structure. Again we will see the cesium chloride structure. So this is a FCC lattice, so face centered cubic lattice with some of the voids. If you see the voids here, there are hexagonal voids are present in the FCC lattice. So hexagonal lattice, if you see hexagonal lattice here, this is the hexagonal lattice. Hexagonal lattice will give you one hexagonal in face centered. How many atoms are present? So face centered, if you see here I am writing in FCC, Z value will be if you take the Z value will be 4. So how it will be 4? So 8 atoms at corner, 8 into 1 by 8 plus 6 into 1 by 2. That will give you the total Z value is equals to 4. Z value 4. That means number of octahedral voids. Octahedral voids are how many octahedral voids is equals to Z value, and how many tetrahedral voids are present? Tetrahedral voids will be tetrahedral voids is equals to 2Z. That means 2 into 4, that will give you 8. So here 8 tetrahedral voids and 4 octahedral voids, so 12 12 total voids will be present. Those voids are occupied by the sodium plus ions that will give you, and at the center of the cubic lattice, one lattice will be there, so that will occupy. That means total 13 sodium plus ions are occupied by sodium, this NaCl NaCl crystal. So again we will see the cesium chloride crystal. Structure of cesium chloride. Structure of cesium chloride. If you see the cesium chloride, it has a structure of BCC, body centered cubic, that is body centered cubic. So you know that what is the body centered cubic is the if I have elements are like this, if I take a cube and one atom present at the center of the body of the cubical structure, so this is body centered cubic. So here chloride minus ions occupied corners. So here Cl minus, Cl minus, Cl minus, and Cl minus, and Cl minus, and Cl minus, Cl minus, and Cl minus. This occupied by Cl minuses, and center will be Cs plus. So here chlorine atoms occupied at the, so Cl minus ions are occupied by corners, and one cesium plus cation is occupied by center. So how many atoms, total atoms are there? So total number of ions are total number of ions, if you see corners 8 ions and one at center, total number of ions is equals to 9. So 1 is Cs plus and 8 is Cl minus, or vice versa. See, or this is also happen due to the same size of the cation and anion. Cs plus maybe it occupies the corner, and Cl minus ions occupies the center. So this may be also possible for this BCC lattice. Next, number of Cs plus ions per unit cell. So number of Cs plus ions per unit cell is equals to 1, and number of Cl minus ions per unit cell is equals to 8 into 1 by 8, that is also 1. So that is cesium chloride unit formula. So unit formula is 1. Next thing is coordination number. So here important thing is coordination number of neighboring group atoms present for Cs plus. So if you imagine, this is the cube, and here 8 atoms are present at the corners, 8 are them present at the corner, and center is 1 atom. That means cesium is present at the center. So how many atoms are neighbor atoms are 1 2 3 4 5 6 7 8. So coordination number will be 8, and coordination number for Cl minus. So coordination number for Cl minus, this is also 8. This is also 8, because if you take here Cl minus, then this side will give 6 atoms. So here one atom. So 1 2 3 4 5 6, and due to the Cs plus, another unit cell contribution 1 atom 7, and this one 8. So total that one also 8. So chloride ions also 8. If you imagine, if you keep Cl minus at the center, then you will get the same 8 coordination number. Don't confuse with the coordination number 6, 6 it should be present, but it is not true, because here 1 2 3 atoms, and here is the 3 atoms, 4 3 3 6 7, and another unit cell 1 CS plus will be there, so both will give you the 7 and 8. So coordination number of the number for Cl minus is also 8. Next, if you see the body diagonals, we know phase diagonals, body diagonals, and in CS chloride touch along the body diagonals. So body diagonals, if you see body diagonal in cesium chloride, ions touch along body diagonal, that means diagonal. So if you see body diagonal means, if I take this one, this body diagonal, so I can draw here. So this is body centered cubic. First you draw a cube you can draw, and only take the 3 atoms. One is from the body diagonal, here 1 atom, and here is 1 atom, and here is 1 atom. So if you draw a body diagonal, this we will call it as body diagonal. So somebody will confuse you, but don't confuse. Here R is the this is a sphere or circle, so this is a radius is R, and here radius is 2R. This is Cl minus ion, this is 2R, and here it is Cl minus ion. So this is everything is equals to, this is 2R Cs plus 2R Cl minus is equals to, how much it is? See, this is A, and this is A. So A square plus A square plus A square plus A square, this is whole square, that is Pythagoras theorem. So this will give you the 3A square. 3A square is equals to, if you 3A square 2R Cs plus 2R Cl minus whole square. So if you write again 2R Cs plus 2R Cl minus is equals to root 3A. So here R is R Cs plus R Cl minus is equals to root 3 by 2A. Sometimes the radius of Cl minus ions and edge length will be given, and find out the Cs plus ion. If you substitute the values in this equation, you will get the value of the RCS plus. So this is about the solid state chemistry.